Welcome to my manufacturing review. In this video I will review this pulley made by the French manufacturer Petzl. The pulley's model name is printed on the box here, Rescue, which is not coincidentally the same as the intended purpose of this pulley. This pulley is absolutely fresh out of the box. It's never been dropped, never been used, a rope has never been placed on it. This pulley is exactly in the same condition as it was when it left the factory. I have all of the instructions and manuals for it. I even have this plastic or string with it. In a manufacturing review, you can think of it as a post-production or post-manufacturing review. I'm going to take a look at some of its observable qualities and features, and we'll make some comparisons. And this rescue pulley, or any pulley, is made to aid in climbing, to make climbing easier. Whether you're climbing trees as an arborist, biologist or scientist, or you're climbing ice crevasses, caves or rocks, pulleys are made to make climbing or lifting loads easier, to aid in climbing in this manner. The pulley features a swivel side plate, which is a little bit jerky at the moment because it's just tight. This tightness is to the benefit of the pulley. There is nothing wrong with it, even though it takes a little bit of effort. And that means that the axle, here is the axle, on which the sheave, this wheel thing, pulleys don't have a wheel because wheels usually are square or maybe domed out, but this one is dished out instead of domed, so this is a sheave. So the axle, the bearing, the sheave and the side plates are tight together, and that's very fine. If this was any looser, then the wheel or the sheave would wobble on it. You don't want that on a pulley. So this is nicely made and it's tight when it's new like this. So the capacities are printed on the side plates here on the pulley. The working load limit is 4 kilonewtons on one leg of the rope. The other leg is also 4 kilonewtons. It doesn't say so, but their combined total 8 kilonewtons is there. So both legs combined. 36 kilonewton number is featured there. That's the pulley's braking strength. WLL stands for working load limit. What the manufacturer has in mind, of course, you can subject this pulley assembly as a product to a load of 8 kilonewtons, 4 on each leg, for repeatedly for extended periods of time without serious deterioration in the pulley's condition. The pulley will break apart and disintegrate subjected to 36 kilonewtons of force. Usually that means a shock load, a load falling and accelerating, and if the rope doesn't break, then at 36 kilonewtons the pulley will disintegrate under tensile forces. The same number is featured over here on this side of the pulley, MBS, mean braking strength, 36 kilonewtons. Mean meaning average. So they had, for example, 10 or so, I don't know, a number of these pulleys. They tested, say, 10 of them or 3 dozens of them, I don't know, of them in testing them to failure, and they failed after all this rounding. They failed at an average of, or a mean of, 36 kilonewtons of braking strength or braking force. This force and this level of manufacturing meets the standards of all of these classifying organizations that you see on the pulley, on the side plate here. And this pulley was manufactured in France. That's where the quality control was also done. The pulley's capability is limited to ropes between a diameter of, that zero that was stroked through on a diagonal is the symbol for diameter, 7 millimeters. Millimeters is not printed there, but it's implied that it's 7 millimeters and 13 millimeters. What happens if you try to feed a rope larger than 13 millimeters is that the dished out curvature of the sheave is not going to be enough. The rope is too fat. It's going to run off a little bit sideways, not run off the pulley, but it's going to rub against both side plates. And a pulley is meant to be a device to ease or aid in climbing, to lessen the effort needed to lift loads. And if you have extra friction on the side plates from a fatter rope, and that's maybe not defeating the purpose, but something along those lines. If you have a rope that's narrower or smaller than 7 millimeters in diameter, it has the potential for extended periods of time, and especially if the rope is dirty. And I just have this pin here that I can hold here that represents a small rope, an undersized rope. It's likely to dish out here the deep part of the pulley wheel, or the pulley's sheave, because as the pulley rolls and the ropes all have embedded dirt in them in use, it's inevitable that dirt is abrasive. It contains sand. Sand is an abrasive material, so it's going to be, the sheave here is going to be dished out at the deepest part after extended periods of time. Not in one rescue where you run 300 meters or 300 yards of rope through this sheave. That's not extended use of time. Okay, so one rescue or two, or if you have, this is about 5 millimeters in diameter, so if you only have 5 millimeter rope or 3 millimeter rope and you have to double it or so to get something done in a pinch, in an emergency, in a rescue, of course the pulley will work with 3 millimeter ropes as well. But the geometry of the sheave and the geometry of the rope is best to be matched, hence the limitation of 7 millimeter here. So the sheave is made of aluminum, the side plates are made of aluminum, the pin or the axle on which this sheave runs is stainless steel, and like I noted before, it's made really nice and tight. This tightness allows no dirt or no contamination that could enter underneath the side plate or inside the bearing of the sheave. The sheave is mounted on steel ball bearings, and ball bearings provide an excellent low rolling resistance. I have a bunch of ball bearings here just for show and tell. This is how ball bearings look like, and they have steel bearing balls on the inside, so when the sheave's pin is put through, ball bearings have really low rolling resistance. An excellent choice for a pulley, where the idea is that they aid in climbing. They make climbing easier or lifting loads as easy as possible, so very low rolling resistance. Now this is not just any kind of bearing balls that they built into this pulley. It's on the box here, and that's why they say efficiency is 95%. There is some friction in everything, including ball bearings, so that's why it's not 100%. It says sealed ball bearings. So let me show you here a couple of variations on seals. Here is this one, which is open on one side, but I left the other side sealed. This is a metal seal. It keeps the dust efficiently and effectively out. It's nice, but even nicer is this very small bearing, maybe from a skateboard or a bicycle wheel or some super tiny angle grinder. I don't remember, but this is a neoprene seal that has, of course, a metal backing, but here where this is the outer race on a bearing, and that inner metal ring is the inner race. Where the races and the seals meet, you can see a groove here underneath my nail, where this metal backing underneath the middle part of the seal is not continued, and it's actually, here is just the neoprene or synthetic rubber contacting or actually sealing here along the outer race and here along the edge of the inner race. This keeps water out of the rolling elements, which is obviously detrimental. This is what happened to, you can see all the corrosion and rusting and black pitting and all of that marks. So this is what happens to ball bearings if water gets into them, unsealed ones or sealed ones over time as well. So this neoprene seal is superior to metal seals. These keep dust out, these keep dust and water out for extended periods of time. I really haven't taken it apart what kind of seal these bearings have. I really don't want to put a grinder to it and grind off the head of the pin, remove it and take a look. But by the time you need to replace this bearing on account of seal deterioration and corrosion, by that time the aluminum sheaves profile will be changed enough that it will be time to replace the whole product. So ball bearings with sealed ball bearings, excellent choice. Another option manufacturers have, and this is just for a contrasting example, so this is sealed ball bearing. Here is a deterrent example, what not to do, and here is a dollar store pulley, unmarked, unrated, unidentified, and if I pull the pin out of it, it's a good piece for show and tell. You can see this atrocious sheave here, which was made by casting, and you can see the casting halves where the mold met there, and it continues to the other side there. Problem with casting made to this atrocious quality is that the rope is going to get stuck or abraded. The rope fibers will be themselves torn on a pulley that's not finished properly. When a rope is placed here, I'm going to use the same pin, there is always slip between the sheave and the rope. Even though they look like they turn together and they move together, there's always a little bit of slip, usually 5%. It's quite invisible unless you mark a spot on the rope and on the pulley or on the sheave, and you turn it together under load. You'll see that the marks will move as the rope moves. It goes from no bend to maximum bend to no bend in the fibers. So there's always slip. This slip means friction. This is why the surface finish on the sheave is critically important. This is an atrocious example what not to do. I sanded off some of this this bronzish finish that they finished this sheave with, so you can see the grooves that are left there by the coarse manufacturing, and of course the rough edges that were in this process of sanding off the finish were also kind of highlighted. So I grabbed a dowel, wrapped a dowel that matches the curvature of the sheave, and sanded it without putting a flat spot on it, just like so, trying to remove that ridge there, and it's still this much visible. So this is a deterrent example. Look at the surface finish of this pulley. It's very reflective. You can see the camera's black lens in it, and because it's a dish-tart shape, it's not really a mirror. You can see some horizontal lines running, well, in this orientation, these horizontal lines on the sheave, and those look like some kind of machining marks, but given the fact that this sheave is this much reflective, it's extremely, and there are no casting lines on it, it's extremely efficient and very rope friendly. If you want to improve on this surface finish, because these horizontal lines are still some kind of machining marks on it, it is possible. Or if you want to improve on the efficiency of any pulley, you can do that with a little bit of metal polish, but you have to remove all of the metal polish. Not necessarily this brand, I just grabbed this because it's flat and I can just have it in my hand. So any kind of metal polish paste can improve the surface finish of a sheave in a pulley, and improve the efficiency of the pulley. It's not necessary that you do it. I'm not recommending that you do it, especially if you don't know what you're doing, because you don't want to contaminate your ropes with an abrasive paste. This is an abrasive material, an abrasive paste. You don't want abrasive particles in your ropes whatsoever. It's really easy to remove it with a paper towel. It's not rocket science. But also what you don't want to do while trying to improve the surface finish, because it's an abrasive paste, you don't want to rub just one spot excessively, thereby creating a flat spot on a perfectly or nearly perfectly cylindrical or circular sheave. Okay, so circularity is just as important as surface finish. If you try to improve surface finish and ruin your circularity, you're defeating the purpose. Okay, so this is a theoretical option, really with much caution. The last item, almost the last item, one more item that I want to show you about the lack of ball bearings. Some pulleys have bushings. This is an example of a bushing where in the sheave a hole was drilled and the sleeve was press fitted. You can see that the sleeve in it is different color from the sheave. Same on the opposite side. It's been deformed to make it. It's just like the rivet. This is a rivet here, and this is the original rivet head on one side. They push it through, and then the rivet sticks out, and they deform the opposite side of the rivet head to make the rivet two-headed. Here is how it looks like. That's the same. A pin looks like with one head, and the other head doesn't get formed. A hole got drilled through it. So this is a sleeve, and that gets double-headed, and the sleeve and an axle interact like so, and they generate more friction force, so they are less efficient because they sap more of the energy required to roll it because of the greater friction. So that's bushing. The instruction here mentions bushings and mentions bearings, and they have different figures of efficiency because the pulley manual is a generic one, as well as a generic one. There are two versions of it, not for two languages, but this is for this is general information, and this is more specific information, and that's why both pulleys made with Petzl makes pulleys with ball bearings as well as bushings. The bushings are for occasional use in a rare or infrequent use in a rescue or a non-load bearing situation, such as a Prusik minding application of a pulley. And this one is for rescuing or for hauling heavy loads. Therefore, a ball bearing was used in it. One last item I want to point out about the side plates is that these side plates, the side plates edges, since we were at the topic of surface finishes, look at the surface finish of these side plates. They are coarse. The side plates were made by a process called stamping. These side plates came from a flat aluminum sheet. They were stamped with a cookie cutter, just an industrial version, and then they were bent to shape. This surface finish is the result of shearing with a cookie cutter. You can see that some of the thickness of the side plate is sheared through cleanly or cut through, and some of it breaks through, and the broken through part leaves a coarser surface finish. The issue with this kind of manufacturing of the side plates, which is called stamping, so making side plates out of stamped or through stamping, is not so much the coarseness of the edge that it leaves, maybe dirt gets embedded in it or whatever in these dimples, but the edge is sharp. I'm not saying it's shredding your ropes or cutting your finger, but it leaves a sharp edge. Now, if this pulley gets hung up on a little bit of an angle and the rope runs through it here and runs off here, it will be in contact with the side plates. Hauling isn't always ideal and vertical, so, and that's why these side plates should really be rounded off. Another counter example, and I really like DMM's pulleys for this person. Look at the side plates here. They are all rounded to a generous about 4 millimeter rounding diameter to it, something like that. You can see this is absolutely rope friendly. Even here at the backet, all of the surfaces the rope might contact are rounded, because this was made by forging. And how the forging die was made, the tool and die maker who made the forging die, they made it rounded, very straightforward. Now, forging does not produce an absolutely perfect surface. Nothing ever is perfect. You can see, if I can manage focusing the camera, that sometimes you can see microscopic small dimples in this rounded edge. Here is maybe 2 of them. There. The problem is that they might collect microscopic amounts of dirt in them, which is no benefit to the rope either. But these rounded edges are not going to be stressing your ropes and severing your rope fibers, especially in the jacketing of your rope. So this is an alternative forging in a nicely made forging die, and this was made by stamping. I don't really like these stamped side plates, and I think I will take one of these jeweler's files or micro files, and we'll even with a Corsair one, and we'll break the edges with a fine micro file such as this on the inside of the side plates from horizontal, there in this orientation, from horizontal down. So only here and only the insides, from here down. The outside totally irrelevant. From here up totally irrelevant. Just from about here down, just a couple of strokes. But should you be doing it? Well, not if you don't know what you're doing. If you're a tool and die maker, absolutely go for it. If this is your first time using a file, then don't bother, really. Don't. So, any tampering of this corner here, of course, is microscopically affecting the strength of the pulley. And of course, if you run with the file inadvertently into the sheave and you ruin the surface finish and put microscopic dimples, because the hardened steel file will make dimples in the aluminum sheave. If you make microscopic dimples in the sheave, metal paste is not going to, or a polishing paste is not going to remove those dimples of displaced metal or cratered out metal. So really, if you don't know how to use a file, or just don't, okay, don't try to improve upon this Petzl pulley. It's nearly flawless as is. Those are some of its limitations that are noticeable, and some of its features. So that's how it looks like when it comes out of the factory. I still like some of the features of this is not the same capacity. These pulleys are made with bushings, but just for, you know, some of the features on this one would be nicer to be seen on the Petzl pulley. But it is what it is. It's manufactured this way so far, and that's room for improvement and rethought on Petzl's part. Thank you very much for watching.